Okay, so we have this claim that 6 divides n times n squared plus 5. And I guess I should put um, maybe for all integers n. Okay, so there's a couple different ways. We could do this by induction. We could get a proof that way. But we're going to come up with a different way. We're going to rewrite this in terms of mod. So how do you write a divides into symbol or divide symbol in terms of mod? Well, this is the same as saying that, I guess, let n be an integer. We want to show that n So these two things would be equivalent. To show that 6 divides this quantity right here would be to say that this quantity is equivalent to 0 mod 6. These two things are equivalent. So if we could show that this right here, that n times n squared plus 5 is equivalent to 0 in mod 6, we would show that 6 divides this right here. We could also say that 6 divides n times n squared plus 5 minus 0. That would be another way to say that, which is essentially how we translated that from this to this. So how do we show this? Since n is equivalent to oops, too many there, 4. Uh, since we know that one of these is true, right, n is, when we use the division algorithm with 6 as our q on n, we're going to find out that the remainder is either going to be 0, 1, 2, 3, 4, 5, or 6. So we know that this integer n is equivalent to one of these 6 integers. In each case, and we're done with the proof. So what do I mean by this? In each case, n times n squared. Well, okay, so you take any integer you want, put it through the division algorithm, and you're going to get a remainder of either 0, 1, 2, 3, 4, or 5. And then let's think about what n times n squared plus 5 equals in each of these cases. So, and I'm putting this as n. What I mean is it's equivalent. It's equivalent to this number, mod 6. So, or I guess I could say this, n mod 6. So this would either be, well, if n is 0, then this whole thing is 0. That would be 0. If n is 1, we have 1 times 6, 0. If n equals 2, we have 2 times 9, which is 18, and that's equivalent to 0. If n is 3, we have 3 times 14, which is 42, equivalent to 0. N is 4, we have 84, which is equivalent to 0. And if n is 5, I'm just going to write these, instead of writing 5, it's nice to think about the wraparound opportunity here. So if n actually equals 5, I could just rewrite it as -1. Same thing here, it's much more helpful. -1 squared equals 1. So we have 1 plus 5. 1 plus 5 is 6. So just to clarify what I did there, I could have done 5 times 25 plus 5. This would have been 150, and that is also equivalent to 0. But instead of writing 25 and 5, I just did a little switcheroo there. Instead of writing 5 mod 6, I knew that -1 is equivalent, so I replaced both of these n's with -1s, and that's how I got this slightly lower numbered example. So in any of these cases, we have 6 different possibilities, but this particular quantity always is equivalent to 0 in mod 6. So that completes the proof. And I think this one is a little nicer than the way I did 6b, so I would recommend that, or whatever the numbering, whichever part B is of this, I would suggest doing it this way instead of breaking it down into 6k, 6k plus 1, 6k plus 5. Just stick with the mods, and it's a lot cleaner.